Okay, so we want to take a look today at explaining the dialysis tube lab. And in the dialysis tube lab, we are really looking at two major phenomena, two major concepts, and that is osmosis and diffusion. Taking a look at osmosis and diffusion, and if you remember back from our notes, osmosis was the movement of water, and diffusion is movement of gases and particles. So let's take a look at the actual experiment. So in this experiment we had a beaker, and in the beaker we have a dialysis tube, and that represents a semi-permeable membrane. And then we put water and we put iodine out here, and we'll take a look at that in our data table as to what color that made it turn. Inside we put glucose and we put starch, approximately a 15% glucose, a 1% starch. That's really not that important, but it kind of gives you an idea of what's inside of the bag. So if we look at the preliminary, so the initial colors of everything that's going on, we see that in the water it tends to be that brown, the brown color that the iodine turns the water. On the inside the bag, we see it's clear, if not maybe just a little cloudy, but it's a whiter color. So we take a look at this experiment, and again we see that the water is going to be our brown color, our bag is going to be clear and cloudy. As we let this sit for about 30 minutes, we are going to look at two different phenomena here. Let's look at the glucose and the starch. In here, the glucose and the starch, obviously, if we remember back from carbs, are two different sizes. Glucose is rather small, very, very small. You put several hundreds and thousands together and we can make starch. So starch is our big polysaccharide. So if we think about this, a dialysis tube is just like a cell. It's semi-permeable. It means it allows things to move in and out, and it chooses what's going to move in and out. In this case, it's going to allow certain molecules to move in and out based upon size. So knowing that, we know glucose is a lot smaller, we're going to see glucose start to come out in the bag. Let's take a look at the final results so that you can see, so we can parallel back to what we have. When we look at the water, at the very end, the water is still brown, but it tests positive for glucose. We put a glucose test strip in there, it'll actually test positive, whereas over here it was negative for glucose. So that's a big conclusion, a big piece that we want to take a look at and really remember, is the idea that somehow glucose has gotten out of the bag and into the water. We now take a look at the bag, and it's really amazing to see it. The bag turns black. So what could be turning the bag black? We've discussed already that based upon size, glucose moves out of the bag. That would be diffusion, that's the movement of a particle. So glucose is moving out of the bag, which is why the water tests positive for glucose at the very end. But starch does not move out here. How do we know? There's a very important reaction. When you mix starch and you mix iodine, and you put those two together, they make a black color. So if the starch were to move out of the bag, then the water out here would be turning black, and it didn't. It stayed brown. It stayed the color of the iodine. So we know that the starch could not move out of the bag, which means it was too big of a molecule, and that's going to allow this right here to stay our brown color and test positive. So now we wonder, why did the bag turn black? We know that iodine and starch, when they meet, that turns black, but we have the semi-permeable membrane. Looking at this, the starch couldn't leave the bag, so it stays in, but the iodine was able to diffuse in. The iodine is a small enough particle as well that it can diffuse into the bag, and then it's turning the bag black because that starch and iodine is mixing together. So in here, we look at this and we see diffusion. We have diffusion of glucose out, we have diffusion of iodine particles in. If you were to weigh this bag, initially, let's say the bag was 5 grams after we put everything in, and of course that's an arbitrary number. It's an arbitrary number in that, it's not the exact number, but if we notice, if we do our final here, we'll see that it maybe goes up to, say, 12 grams. What is causing that gain in water? Well, think about this. Out inside the bag, we have all this glucose and all this starch. So talking just in terms of water potential, we have more solute, which means we have less water inside. Out here, we have a whole beaker full of water and very little substrate, very little particles or substances. So our water is more concentrated outside of the cell than inside the cell. Which means if we know, and I'm just going to draw this as sort of a kind of a thing here, that if, let's give it a number, let's say that's 5% water on the inside, and let's say it's 20% water on the outside. Again, just choosing numbers to show the relationship. We know that water moves from high to low concentration. That's why it's passive transport. So the water is going to move from outside into the cell. This causes the cell to swell up, which we learned last week, or is called cytolysis in the last class. And that is where the cell is going to swell and eventually burst. This process where water is more concentrated on the outside than the inside is called what kind of solution? That's right, it is called hypotonic. Hypotonic, remember if you remember the word hippo, hippos are big and fat and take in water. Water is moving into the cell. The opposite of hypotonic, of course, is hypertonic, and that's where the water would have been moving out of the cell, but we don't have that situation. So this is a quintessential case, an experiment that really does show a lot of initial movement of particles for diffusion, a movement of water to balance out and maintain that homeostasis, that equilibrium, through a hypotonic where the water is moving in. But really just a good example of seeing both osmosis and diffusion happening, and yet we didn't put any energy in. This is why it is passive transport. So that is the dialysis tube lab, and I hope that helps.